Chemical bonds, shared paths. What is a chemical bond really? We are shown sticks between balls or shared electrons as dots. In energy filament theory, a bond is not a stick and not a rope of electrons. It is a shared low-effort path that the energy C opens between atoms and then locks in. Start with one atom. Its outer electrons are not parked beads. They are filament rings running along stable orbits. Each orbit has its own rhythm and swirl. Over time, these moving rings carve a patterned texture around the atom, like a tiny wind field with a preferred direction and beat. That outer texture is how the atom speaks to the world. Now bring in a second atom. As their texture fields overlap, they do not ask how heavy are you. They ask, in which directions do our patterns match? The spiral traces from each atom's electrons create possible matching grooves in space. If at some angle the directions and beats line up, the energy C quietly stretches a corridor between those regions. Along this corridor, it costs less effort for an electron to move back and forth than to stay locked to just one atom. The electron begins to oscillate along that path. Each pass smooths the rhythm, and the corridor grows more stable. That shared corridor is what we call a chemical bond. Seen this way, shared electrons means something simple. The electron spiral texture is now imprinted into both atoms at once. To the energy C, they form one combined pattern, not two separate atoms that just happen to touch. If the corridor is almost symmetric and the electron runs most easily in the middle, we call it a covalent bond. If one side's texture is tighter, the electron spends more time on that side, and we see one atom as positive and the other as negative. That is an ionic bond. When many atoms open many overlapping corridors and electrons roam across the whole network, flowing wherever the slope is easiest, we get metallic bonding. Heat, stress, or a change in tension can scramble a corridor. The electron's rhythm no longer matches at both ends. The path stops being low effort, so the energy C simply withdraws it. The bond breaks and the atoms go their own way. Reverse the story and you get bond formation. Whenever two outer textures find a matching beat and direction, a shared path grows almost by itself. A molecule is just a stable cluster of such shared paths in the energy C. Tap follow, share it on New Physics, Clear Universe.